Hi everybody. This session is to review the concept of AC power. We'll just go ahead and solve examples. Example number 1. We have two elements in series. The current through these two elements is I of t and defined by 4.24 cosine 5000 t plus 45 degree. The power consumed in this branch is equal to 180 watt. The power factor is equal to 0.8 lagging. So what are these two elements? Well, to find the elements, it means that we need to find is it R connected to L or R connected to C. First of all, when we are working with power, we have to use root mean square value of the voltage and the current. So the root mean square of the current is equal 4.4 divided by radical 2, which is equal to 3 ampere. So the current as a phasor is equal 3 ampere on angle 45 degree. So that's the current through the branch. Of course, one of the elements is resistant because you got consumed power or active power here, which is equal to 180 ohm. The power is equal I square magnitude times R. Maybe somebody will ask why I'm using I square times R, why I'm not using V square over R. I'm using I square times R because the current is given in this problem. And the current in series in both elements. So the current in R is the same the current in this element. That's why I'm using the current. If it was in parallel, I will use the voltage across the resistor. The current magnitude is equal to 3 square times R. I don't know it, but I know the power is equal 180 watt. From this equation, I can find R. R will be equal to 100 watt divided by 3 square. I get 20 ohm. So now one element is known. The resistance is equal to 20 ohm. If we sketch the power triangle, the power is 180 watt. Q, I don't know it. But can I find the angle? Yes, you can find the angle. Why? Because power factor is given. If there is any relation between power factor and the angle theta, yes. Power factor is equal cosine theta. So theta is equal cosine minus 1 power factor. Cosine minus 1 and the power factor is given 0.8 lagging. So the angle will be equal to 36.87 degree. And it was given it's lagging. Since it's lagging, this element is going to be inductor. So that's QL and this element is L. I want to find Q. How you find Q? Q divided by P from the power triangle is equal 10 theta. So Q is equal P times 10 theta. So Q is equal P is equal 180 watt times 10 the angle, and we know the angle now is equal 36.87 degree. So Q will be equal 135 volt ampere reactive. Once we found Q, we can find XL because the relationship between Q and XL, Q is equal I square XL, and I, we found it's equal to 3 ampere. So you got 3 square time XL equal Q, which is equal 135. So XL will be equal 135 divided by 3 square. That will be equal to 15 ohm. So XL is equal 15 ohm. But it was required to find the elements. It means we find R and L or R and C. XL is equal omega L. And omega is giving 5,000. How I know it's equal 5,000? Because it was given the current is equal this magnitude cosine 5,000 T. So omega is equal 5,000 L. So L is equal XL 15 ohm divided by 5,000. It will give you 3 millihenry. So now we know that the branch consists of resistor and inductor. The inductor is equal to 3 millihenry and the resistance we found out is equal to 20 ohm. So problem is solved. Okay, let's move to the second problem. We have two parallel branch capacitor. Its reactance equal minus G2 in series with the resistor equal to 5 ohm in parallel with resistance equal to 4 ohm. And there is a current IS feeding this branch. The current is given equal to 42.4 angle 0 ampere. What's required? Find the total power information. When this is mentioned, power information, it means find SPQ power factor. That's the information, the total information of power. All right, so let's see how we can solve this problem. Okay, to find the power, you got power consumed here in the 4 ohm and you got power consumed 5 ohm. So that's the first thing. The only reactive power Q, it's consumed in the capacitor. So if you found Q in 4 ohm, if you found if you calculate the power consumed by 4 ohm and the power consumed in 5 ohm and add them, you got the total power consumed in this circuit. If you find the reactive power delivered to this capacitor, so you find the Q total, the only one, the only stored element in the circuit. And then if you draw the power triangle, putting P total, Q total, you can find AC total and power factor. So just let's go ahead and see how we can find the power in each. Well, IS is going to be divided into two currents. Let's call this one I1 and this called I2. Okay. How can you find I1 and how can you find I2? Using the current division rule. So I1 will be equal the total current IS, which is 42.4 angle 0, time the opposite resistance, which is 4 ohm, divided by the total 4 plus 5 plus minus G. So to be 9 minus G2. And that will be I1. It's equal to 17.88 on angle 18.43 degree ampere. I2, it will be calculated in the same way, equal to the source current 42.4 on angle 0 time. If you want to find I2, so you multiply by the opposite impedance, which is equal 5 minus J2. So time 5 minus J2 divided by the total, which is 9 minus J2. So I2 will be equal to 26.05 on angle minus 12.53 ampere. Now we found I1 and I2. Let's find now the power consumed in 4 ohm. So let's call it the total power. It has two power. Power consumed in 4 ohm and the power consumed in 5 ohm. The power consumed in 4 ohm, you have the resistance equal 4 and the current is equal I2. So we'll say 4 times I2 square, magnitude only. That's the current magnitude, will be 26.05 square. So that will be the power consumed by 4 ohm. Power consumed by 5 ohm will be 5 times I1 square. You get the I1 magnitude, which is equal 17.88 square times 5 ohm. And then you add them, you get the total power would be equal to 2156 watt. Now I want to find Q total. Well, Q total, you don't have any reactive power except this one delivered to the capacitor. So this XC is equal to, and the current is I1, so I1 magnitude square times XC. I1 magnitude is given 17.88 square times XC, which is equal to 2. 2 is equal the reactance of the capacitor. That will be equal to 480 var. So you got the B total, you got Q total. If you sketch the power triangle, it will make it easy for you to calculate the rest. The Q total is equal 480 var. The power total 2156. Excuse me, 2156 watt. So now we can find S total. That's S total. Using Pythagorean, it will be 2156 square plus Q square, 480 square root. You get the S total be 2209 volt ampere. To find the power factor, it's the ratio between the power and the S. The power is equal to 2156 divided by S, 2209. It will be equal to 0.976. And obviously this is lagging power factor because the Q in the positive direction. So this problem is done. Okay, so let's move ahead to another problem. You have two impedance, that's Z1, that's Z2, and the voltage across this branch is given Vs. Vs is equal to 28.28 angle 60 degree volt, and it's giving that this is the root mean square. So you don't have to divide by radical 2. What's required? It's required to find the total power information giving that Z1 is equal 4 on angle 30, Z2 is equal to 5 on angle 60. Oh, okay. That's simple one. To find the all information, it means you want to find S, P, Q, power factor. So first you find the voltage, find the power, the reactive power, the power factor, total power in Z1, and the same for Z2, and then you add it. You add the power, you add the Q and thing. Well, to find the power, as I mentioned in the lecture, it's better to use the complex form. So we mentioned that the apparent power or the total power is equal V times I conjugate. I have now two in branch. I have S1 and S2. So I want to find S1. So S1 will be equal V, because the voltage here across the Z1 and Z2 are the same, Vs, okay? Vs, and the current through the first branch I1. So I will say I1 conjugate. but I don't know I1. Can you get I1? Yes, of course you can get I1, but I don't want to get it now. Just I wanna find expression to make it easy using only the voltage. So VI conjugate I1. Well, what's I1? Well, I1 is equal the voltage divided by Z1. So equal V by Z1 as vector, Vs. But I don't need I1, I need Y conjugate, I1 conjugate. So I1 conjugate will be equal to Vs conjugate divided by Z1 conjugate. Now use this expression in S1. So S1 is equal Vs time I1 conjugate, here I found it here, Vs conjugate divided by Z1 conjugate. When you multiply a vector by its conjugate, you get the magnitude square divided by Z1 conjugate. Okay. V magnitude square, V magnitude 28.28. So 28.28, and you are not going to take any angle because it's already are only taking the magnitude. This time the conjugate divided by Z1 conjugate. Z1 is equal 4 on angle 30, so the conjugate be 4 on angle minus 30. Calculate this expression. You can find the S1 as a complex number. It finds equal to 200 on angle plus 30. So let us write here in the new line S1 we found it equal to 200 on angle 30 converted to complex form would be equal to 173.2 plus J100. So the real part will be P1 and the imaginary part will be equal to Q1. And obviously this is inductive load because you have plus J in the power. The same way we are going to find S2. How to find S2? S2 is equal the voltage times I2 conjugate. The voltage and I2 is equal the voltage divided by Z2 conjugate. So it will be Vs times Vs conjugate divided by Z2 conjugate. So it will be again Vs magnitude squared divided by Z2 conjugate. Vs squared the magnitude only square. The magnitude is equal to 28.28 square. Z2 conjugate, it's 5 on angle 60 will be 5 on angle minus 60 because conjugate. Calculating this will get the vector form. It is equal to 160 on angle 60 degree and the unit VA, volt ampere. If you convert it to complex form, you'll find it's equal 80 plus J 138.6. Again, that will be the power, but that will be the power in the second branch, B2, and that will be equal Q2. Now you have B2, Q2, you have B1, Q1, you add them, you can find B total is equal to P1 plus B2, and Q2 total is equal Q1 plus Q2. So when we add these two values, we'll find out that the total power will be equal to 253.2, and the total reactive power is equal to 38.6. So the S total will be equal to, how we write it, B total 253.2, this value, plus J 238.6, that's S total. You may convert it to polar form, which is equal to 348 on angle 43.3 VA. So that's the value of S, and that's the angle. You can get the power factor by finding the cosine, the angle cosine 43.3, or you can divide it B by S, 253.2 by 34, you get the power factor, which is equal to 0.728, and it's again lagging. Okay. Let's go to the last problem, which is important, because we're going to talk about how to correct the power factor. In this example, we have load supplied by the power supply, 120 voltage, 60 hertz. And this load, the Z of the load is giving equal to 20 on angle 30 ohm. It's required to connect capacitor in parallel with the load to make the power factor equal to 0.95 lagging. So they want to improve the power factor. So what is the value of C that it will make the power factor equal to 0.95 lagging? Okay, that's a good problem. You got to focus on this one. Well, first of all, you should find the power and reactive power in the circuit before you connect the capacitor. Again, use this magic rule. S is equal VI conjugate for the load. Again, we are going to say the current. Of course, now we're not connecting the capacitor. Just to let me remove it here to make it clear. I'm not including this in my calculation. So the current is going from the source, going to the load only, nothing, and it's not connected yet before connecting the capacitor. So the current is equal voltage over Z, and we need to find the total power or apparent power. S called apparent power. So you have to make the conjugate. So again, as we did before, be equal to the voltage magnitude divided by the conjugate of the impedance. So S load is equal to V magnitude, which is equal to 120. Again, I will say this is the root mean square. If it's not the root mean square, divided by radical 2. So we have 120 square divided by Z conjugate. Z is equal to 20 on angle 30. So it will be 20 on angle minus 30. And that will give you the total power or apparent power S, which is equal to 720 on angle 30. If you convert this to complex form, you will find it equal 623.5 plus J 360 volt ampere. If you sketch the power triangle, that's your power triangle. Here is the power 623.5 that's consumed by the load, and that's 360 var. That's used by the stored element energy inductor, and this is what, and the angle it's already given 30. Okay, so it's required to improve the power factor. Well, if you want to know the power factor of this one, the old one, if you are curious, it's not required, but just if you're curious, you can divide the power by S. So the power here is equal 623.5 and divided by S, which is equal to 720. If you just calculate using my calculator here, 623.5 divided by 720 equal to 0.866 lagging. So that's the power factor. They want this to be 0.95 lagging. It means that you are going to get it like special angle, another angle here, because they are going to reduce the Q. So they want to remove all this power. So first you have to get the new angle. How can you get the new angle? Well, you get the new angle using the new power factor. The new power factor is equal cosine minus 1 0.95. Because we know cosine the angle is equal power factor. When you do that, you'll find the angle is equal 18.19. So this angle, in theory, it's going to be reduced to 18.19. What it matters to me, this value. This is, would be done by the capacitor. So this should be equal to QC. QC is going to cancel this part to have the new Q here. Well, that's, it means your new triangle, actually, if you sketch your new triangle after you have the capacitor, that will be your new triangle. You got 18.19 and you got your new, that's the new one, all right? And the power doesn't change because, you cannot affect the power. You consume it there. So you can't, you should not reduce it. It's not involved in the problem. Q the only one. So can you calculate the new Q? Yes, you can, because you know the new angle, 18.19. You know that Q, I'm talking about the new, the modified one, divided by the power, which is 623.5, it's equal the tangent of the angle 18.19. From this, you can calculate the Q new. So the new reactive power that you wish to have it in this circuit is equal to 204.9. Just let's round it, make it nice number, 205. So I'll say the new one is equal to 205 var. So that's the 205, the new one. The old one was 360. So the difference, where it will go to the capacitor. So now I can say the Q of the capacitor, it's the difference between the old Q and the new Q. The old Q was big, 360. The new Q is smaller, it's 205. And the difference between both Q will be equal to 155 var. So you need to cancel this amount. This amount, 155, that's for QC. That's the capacitor will produce in the opposite direction. So now that's the QC. How you find QC? You see now, you remember when I told you when you calculate the power or the reactive power, you may use I squared times X or V squared over X, it depends on the situation. When you go back to the circuit, you'll find that the capacitor, when you connect it, you're going to connect it in parallel to the impedance, which is the same voltage. So I'm going to use the voltage form, not the current form, because the voltage already know. So I'll say that the QC is equal the voltage across the capacitor squared divided by XC. The QC is known is equal 155 and the voltage is known is 120 square over XC. From that I can find XC. So XC will be equal to 120 squared, the voltage magnitude, divided by 155. So you will get the value of the XC in ohm, but it is required to find C. So what's the relation between XC and C? XC is equal 1 over omega C. It means C will be equal to 1 over omega times XC. So C will be equal 1 over omega. Omega is equal to pi f and the frequency equals 60. So this is omega here times XC. XC you already calculate from this one. You calculate from this value. This value XC is equal 120 square divided by 155. So put 155 in the top. And then you calculate, you find is equal 28.5 microfarad. So you did good design. You found the value for the C that if you put it in parallel with the load, you can improve the power factor to be 0.95. And that's all, folks. I hope you enjoyed and good luck. That was the last revision session.